In this video we are going to review the oligopoly model of Stackelberg. Stackelberg is going to be a two-firm model here, each firm again producing identical goods. The only difference between this and Carnot is that one of the firms gets to set its output before the other firm, and so that's what we're going to do here, look at how this model shakes out. We're going to use the same market conditions that we used in Carnot. Got an inverse demand of P equals 100 minus Q, where that output is coming from firm 1 and firm 2. Substituting in Q subscript 1 plus Q subscript 2 in for uppercase Q, the inverse demand equation becomes what we have here. And then simplifying that slightly, we get this following result. So let's do this from firm 1's perspective. We'll assume that firm 1 is the first mover, the Stackelberg leader. This means that firm 1 sets its output, then firm 2 observes firm 1's output, and then sets its corresponding output level. So when firm 1 is deciding on how much to produce, it needs to consider how firm 2 will respond to its output level. And the way that firm 1 is going to do that and incorporate that information is to consider firm 2's reaction function. Firm 2's reaction function is given by the following. We found that result from the Carnot video. So if you can't remember that, you might want to review the Carnot video to figure out how to get a reaction function. But firm 2's reaction function is given by the following. So what we're going to do is we're going to take firm 2's reaction function and plug it into the inverse demand equation. This is how firm 1 will incorporate how firm 2 responds to its output choice. Simplifying this result, we get that, and simplifying further, we get the following. Now this becomes a standard profit maximization problem from firm 1's perspective. We're going to take this inverse demand faced by firm 1 and we're going to solve for marginal revenue and then set that equal to marginal cost. So let me go on to the next page to do that. Rewriting firm 1's inverse demand equation, getting marginal revenue for firm 1, and now setting marginal revenue equal to marginal cost. Okay, marginal cost is just 40, just like the Carnot problem we did. Solving for Q1, firm 1 wants to produce 30 units of output. Now to figure out how firm 2 is going to respond to that, the optimal output for firm 2 is to take firm 2's reaction function and plug in 30 for Q subscript 1, and firm 2 will produce 15 units of output. So in our Stackelberg solution, firm 1, the first mover, produces twice as much output as the following firm. And this is a standard property here, once again, of Stackelberg problems when you have both firms having the same cost structure. The next thing here, let's get the going market price. So price equals 100 minus total industry output of 30 plus 15. Or $55. And that is how you do a stackelberg problem.